principal stress, and what is a principal plane, then what is a principal direction. These are the three things, So you have, because at the same point when we rotate the element, see this is the element, this is x direction, this is y direction, so this is the element. At the same point now I am rotating, so at the same point we define stress at a point, depends upon the plane on which we are talking. So it can be this plane, it can be this plane, it can be this plane. So we are rotating the element, so this stress on this plane that is acting, that is changing its magnitude. I mean, in fact there are two components, so there are two stress components, so they are changing their magnitudes as you turn this around the same point. There will be one direction when you will find that this normal stress is maximum, and that direction is called principal direction. The plane on which, the plane is called principal plane, and it so happens that if you find that if this is the maximum, you will find that shear stress turns out to be 0. That we will prove just now. So shear stress comes out to be 0. So on a plane on which normal stress is maximum or in the principal direction, you have only normal stress, no other stress. Okay, so that is the concept of principal stress. And if you have any doubt, then you please ask me. Okay, so we are talking about this is the title, principal direction, principal stress, So I have a now you must have we got it, this one, sigma x dash sigma x plus sigma y by 2. There is some amount of repetition, I cannot avoid it. So this is this plus then what? Plus and again plus please do not talk, and then sigma y dash is this minus this is okay? This is all right or not? When theta becomes theta plus 90, so this is sigma y dash, is this becomes sine this this one, no, this one will be this will become cos minus second term will be cos. So this negative sign is okay? This will remain cos. Yes. Sorry. This will remain cos. Yes. 100%. Yes, you are right. And this sign only changes. Yes, because okay. And if you add this, so one is just add these two quantities, two normal stresses. So this one was and then this is of course shear stress also is there. Diagram has to be drawn very neatly, no hodgepodge diagram, you know. So this is, I am not, so this is at the same point P. Please add it, and then you find that here this plus this becomes 0, this becomes 0, this half plus half, so it is sigma x plus sigma y. This is a very good result. Sum of normal stresses with respect to any set of coordinates, sum of normal stresses. See, this will become always 0, plus minus, same, everything is there. This is for any theta, so this is 0. So with respect to, so I can generalize this will be double dash, some other axis also. Yes, therefore it can be, it will always be with respect to any set of orthogonal coordinates, sum will always be equal. This is one test. This is called first law of invariant. Invariant, sum of stresses, normal stresses remain the same with respect to this plus this and this plus this will always remain same. So this is called invariant, first law of first invariance. So this does not change. I think first law is only important here for plane. For plane, second law will not be. Okay, let us see. Anyway, remember this. So this is one good result. This and then I will tell you about the other one. Then we also got tau x dash y dash, and that was equal to minus this is plus, na? No, one is negative. Huh? Tau x dash y dash, who will prove? I don't want to go through the derivation. You are saying both are positive? Yeah, I will have to see. Huh? You have derived. I don't want to go through the derivation. Which chapter is this? Transformation of stresses. Yes. Nahi bhai, if you sum all the forces in y dash direction, this one is negative, like this, sin 2 theta, this one is plus, and x dash is correct, x plus cosine 2 theta, sin 2 theta, y dash as usual, y dash also we have done 90, I think that day we derived this, minus cosine 2 theta, and this is minus, so ye sahi hai, this is okay, this is all right, this formula. So please check your derivation. Yes. So we must do this. So I have a simple problem. So this is chapter 1. So I have a okay, so there is a problem, that is example. This one is 18 kilonewton per meter square. This shear is 6 kilonewton per meter square. Sigma y is 8 kilonewton per meter square, and this shear, how much it should be? How much it should be? This one, same, it has to be same. So the question doesn't arise. So this point is P. Alright, so please find out at an angle 60, when you rotate this element by 60, a degree of 60. So this direction is such that it is making an angle. This is x, this is x dash, and this angle is 60. Yes, so please find out the values of stresses when this is rotated by this point P remains the same. This element is rotated by in anti-clockwise by 60 degrees. So please find out the stresses on its planes. Now you will find, go through just substitute in the formula. Anyway, so this is, I have drawn the direction, but then how did you get the direction? That I will tell you, that is from the formula. So this comes out to be sigma x dash when theta equal to 60 equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into what? Cosine 120, 2 theta, so 120 degrees, and then plus or minus, plus plus tau xy into sine 120 degrees. So please find out what is this value, and similarly please find out this value, x dash y dash at theta equal to 60. So that is equal to this yes please. So this is what? Tau. Yes, this is tau. So this turns out to be that sigma theta, sigma 60 degrees. How much is it? 18 plus 8. 18 plus 8, 26 by 2. 26 by 2 is 13. So it is 13 plus 18 minus 8, 10. 10 divided by 2, 5. Into cosine 90 plus 30. Plus tau xy is how much? 6. 6 into sine, again 90 is pi by 2 plus 30 degrees. So please find out the values. So this comes out to be 13 plus 5. ये क्या हो जाएगा? ये cosine 90 plus its second coordinate, हाँ माइनस हो जाता है, minus sin 30 ना, cosine becomes minus 30, हाँ. So this is minus sin 30, and then sine will become what? Huh? Plus cos 30 plus 6 cosine 30 degrees. So tell me, so 13 minus 5, and sine 30 is 1 by 2. So 1 by 2 plus 6 cosine 30 is root 3 by 2. Huh? Cosine 30 is root 3 by 2. So that comes out to be 13 minus 2.5 plus 3 into root 3 by 2. 3 plus 3 into root 3. 3 into root 3. Root 3 is 1 point. I play 732. 1.732. You know what is the how to remember whether it is 414. Root 2 is 1.414. Root 2 is 1.414 and root 3 is 1.732. How do you remember? Come on, one person. Palas, tell me, how do you, root 3 is 1.732. How do you remember? You just remembered this. Huh? Root 3 is an important quantity. So, how do you remember root 3? Anybody in the class? Anyone in the class? How do you remember? How do you keep in your mind? See, even after 60 years of my 11th standard, not 60, I think 55, okay. Not 60, about 50 years. 50 years of my school, I still remember, my teacher had told, you remember this, root 3 is, I believe you, it means nothing, but then he said, I believe you so. 1.7, this has got 7 letters, 1, 2, 3, 4, 5, 6, 7. And so this is 17. This is 1732. So this I still remember. Root 2. I will tell you. Root 2 also has got a formula. Okay. So anyway, this is how much, please? कितना हो गया ये? How much? 15.7. So it is 15.7 kilonewton. Now, whatever this calculation simple is there, this has to be done on your notebook. When this question, this is a simple thing. It's just substitution and calculation. And here, if you make a mistake and come here, then you are not an engineer. Okay, sir, I have a method, I have written the formula right, but I have got this mistake I did, sir. No, you deserve only 0. We can't give you anything else. So remember this. It has got simple, you have to write it clean, in a clean manner. First of all, it will not be written in a clean manner on your notebook. It will be all something, which we have to, it will be modern art. So which you have to decipher what it means. And then finally you will say, I made a mistake. So you made a mistake. So that is what is the thing. You must do it systematically, step by step. So so this is okay. So this is right. This is 15.7 is correct. Then what about the other one, sigma y? What is sigma y? Sigma, that is sigma 30 you have got, 60, that means x dash. What about 90 plus, what about sigma y dash? Y dash, that is sigma 60 plus 90. So substitute and find out. Anyway, you can find out that value comes out to be 10.3. Then tau x dash y dash, that is 60 degrees, that will come out to be minus 7.3. Very good. And that is why I have drawn that element on the previous. See, I had shown the direction. So see, here it is this direction, positive. Here it becomes minus. So sign has to be, so finally you have to show that this value is, make a big diagram in your notebook, that this value is this much, this value is this much, this is 10, this one is 15.7, of course with units, and this value is 7. Don't now, after showing the direction, don't write minus. This value is 7.33. All units are in. So once it is drawn, there is no, and finally you should show it like this at the end of your question. What happened? 10 point? How much? 10.3. Okay, 10.3, yes. So we wrote 10.3 na? 10.3. Here also 10.3. And then over here, complete it. This is not, element cannot remain in equilibrium just with these positive faces. Completed. Having found out this, then the element cannot remain in equilibrium. Sum of forces must be equal to 0. So please complete it and show it here. This is 10.3. This is 15.7. This is this much. Signs are, they don't come at random. Signs has to be properly shown. And this is 7 point. नहीं गड़बड़ हो गया भाई, साइन तो गड़बड़ हो गया. दिस इज okay. So this is how it is done. So this is the final answer. And now you can see that 7.33, sorry, 15.7 plus 10.3 is equal to 0, 16, and then 2, 26. And what was the original? Original was 18 normal plus 8. That is also 26. So sum of these normal stresses, check it. You have to check it. This is checked now. This is a check. And this also you have to show. Not that you have found out that the normal sum of normal stresses always are, they will remain same. So original was sigma x and sigma y was this much, 26. Now it is 15.7, 10.3. So please check. Yes, this is okay. So that one is that completes. So when a simple problem also is given, we expect this much from you. It is next principle. So I had shown you, I have given you only the not the quantitative but the qualitative way in which I have explained that yes, there will be a direction, then when it will be maximum. So the best thing is you please find out this derivative of, you take sigma x is given by, sigma x dash is given by sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cosine na, into cosine 2 theta plus tau xy by 2 into sine 2 theta. So to get principal direction, to get set that equal to 0. So this comes out to be how much? Cosine 2. So it will come out to be sigma x minus sigma y. First one is 0. So this is 2, and cosine sine, derivative of cosine is how much? With a negative sign. With a negative sign. So 2. So 2 theta means 2 into sine 2 theta. This 2 and this 2 will go, plus 2 times tau xy, because sine 2 theta, cosine 2 theta, then 2 theta 2. So 2, this is equal to cosine 2 theta, and this is equal to 0. Therefore sine by sine, I think I should take tangent. Yes, okay. So tangent is therefore twice. Therefore sine 2 theta by cosine 2 theta. Call this the direction 1. This direction is my theta 1 direction. 1 is principal 1 direction. Let us define this as theta 1. So that is equal to, minus sign is there, so this is equal to tau xy two is there, 2 times, no, 2 is there, yes, 2 is there, so 2 I will bring the 2 below like this, yes. So the direction theta, principal direction, can be found out from this. Therefore your theta 1 direction is principal direction. And that is equal to tangent inverse please find out inverse of this quantity, so that can be found out. Now this, it can also be seen graphically. This is what is given you in your book, and if you substitute this value of theta into your formula for sigma x dash, this is the direction, so I will substitute this value of theta into the formula for sigma x dash, that means here, so I will get my sigma 1. So please substitute, so substitute this in sigma x dash, and then you get sigma x dash. It can be maximum or minimum, because first derivative of any function, it gives you only maximum or minimum. one of the two, maximum, minimum. And then so let us call that these values as sigma 1. Yes. Half has come here. Oh, yes. That is right. Tangent theta 1 is half of this, yes. 2 theta. So here, this one is 2 theta, yes. That is right. Yes, this is 2 theta. This is here is 2 theta. So here if I want, so here I must put here half. That is okay. This is okay. So this comes out to be, if you substitute this value of tangent 2 theta 1 into this formula here, find out. I think it's not difficult, because tangent 2 theta 1 is tau xy. So please make a triangle. Take a triangle here. This is 2 theta 1. So this is tau xy, and this is sigma x minus sigma y by 2. This is hypotenuse, this is base. No. Hypotenuse is this. What is this called? What is this called? Triangle, right angle triangle. Perpendicular. But there is a name, just like we call this base, this is what is called? There is a particular word. So what is the value of this diagonal? Diagonal is this much. So you can use this, and so because sine will come, sine is equal to this divided by this, and cosine will be this divided by this, under root this, and if you substitute this, you will get, silence please, sigma x plus sigma y by 2 plus minus so these are the maximum values, maximum or minimum. Yes please, this is the principal values. These are, one of the two will be principal, one will be minimum. Maximum value is called principal stress, not the minimum. They always appear in parallel. One will be, right. So this is what you can get. Is it okay? You can get the values analytically. But this one, yes, by usage you should be able to remember this. This you must remember with sign properly. Okay, so this you can do it. All right, so this is these are the sigma x plus sigma y by 2 plus minus under root sigma x minus sigma y by 2 whole square plus tau xy whole square is these are the principal values. One of the two will be principal value, other one will be minimum. One will be maximum, one will be minima. That always happens. Now shear stress on this, if you substitute this value of theta in the expression for shear stress, when you substitute, that is what I want to, because earlier I had told you, by just this is 35. So now shear stress is given by what? Sigma x minus sigma y by 2. There is a negative sign here, minus sine 2 theta plus tau xy cos 2 theta. So let us find out tau xy. this one with reference to 1 and 2. With reference to 1 and 2. 1 and 2 direction you have found out already now. What is your 1 and 2? Yes, you have got 1 and 2. This is my principal. This is my 1 and this is 2. No, I mean, I will show you. So okay, substitute. So minus sigma x, sigma y by 2, and sine is given by sine 2 theta from this triangle tau xy divided by under root see, although these things appear to be very simple, but first time you have to do it in longhand, then only you will remember. If you read from the book like a history book or from the notes of your friend, because you have not come to the class, so you did not write. And many people come here and they don't write notes, they don't take down. They are very, they have got photographic memory. Everything gets registered and then they can recall it in any time. So this one plus tau xy multiplied by cosine 2 theta. Cosine 2 theta is sigma x minus sigma y by 2 base divided by under root please add this. Take the LCM. LCM is this. On the top, you have got minus sigma x minus sigma y by 2. First expression multiplied by tau xy. Second expression plus tau xy multiplied by, so it is 0 divided by this, and therefore it is 0. So on this there is no, on this plane direction 1 and 2 you will find that shear stress turns out to be 0. So only there will be normal stress. So this will be only normal stress. Of course, you have to find out corresponding to which theta 1 and theta 2, which one is maximum or which one is minimum. You have to substitute and get the value. You have to substitute in the expression and get the value. Then you will know which one is giving you maximum and which one is minimum. So this is the, and this is very important. What is the use of this, finding out, doing all this algebra and then, see, this is algebra. So why should you do this? Tell me one person. नाम पूछना पड़ेगा. विवेक खानजोड़े, हाँ बताइए. What is the use of doing all this? Why are we doing this? Finding out principal direction, then finding out the values sigma 1, sigma 2. इसकी क्या जरूरत है? Why not just sigma x? Be happy with sigma x, sigma y, tau xy. So, no, but what is the purpose? What is the need for finding out these values? rotating the element and finding out the direction. Yes. बैठिए. See, when you design material, let us say steel is there, stress is acting. So if you have found out this direction 1 and 2, so you know that the maximum tensile stress is occurring along or compressive stress, whatever it is. See, this can be compression or tension, it can be both, direction can be negative or positive, that is a different matter. So you can find out this is the maximum stress, normal stress that can occur. Then you can really see whether the steel which you have, supposing this value is coming out more than the sigma y yield of steel. You are designing a structure, a beam, and this value sigma 1 is coming more than sigma y. Sigma y means what? Yield. So what will happen? Material along that will fail. It will go into plasticity. We don't want material to fail. So it helps us to design the member. You should know in advance what is the maximum value. Okay? Unless you know, how will you fix? So you have to change the dimensions of the beam and then again analyze, then again find out, okay, now reduce that value so that that stress value reduces, maximum value reduces, and it becomes less than the yield value of the material. Otherwise stress will exceed the yield value, and obviously it will go into plasticity. It will start flowing. Flowing means it will, as you know, once it starts flowing from one, so it plasticity grows. I think I have told you also ultimate load analysis. Find out the ultimate load of the beam, that from how it grows from top to center. It starts at the top because maximum stress, and then it grows inside. So once the material starts flowing at one point, then it will spread and the entire member will fail. So this is for designing, to make a safe design. So everything that we are doing is for safe design of structural elements. Neha is sleeping. No, not. Or is Mittal. Yes. What is your first name? Asima. Asima. Seema Mittal. Seema Mittal. Okay. So, no, there is some problem with my memory cells, so they are drying up now. So, I don't want to burden my brain now, with too many information. So, okay, so this is, now similarly you also must find out what is the value of, okay, this is done, one. Then what is next? Next you should find out also when there will be one direction in which you will find, you watch only the shear stress component. Shear stress will be maximum. Shear stress component for that direction will be maximum. So please find out what is the direction for which shear stress, tau xy becomes maximum. Next, maximum shear stress. Compute maximum shear stress. Is it okay? I mean, have you understood? We have done normal stress maximum. Now we want to do maximum shear stress. Why do you want again shear? Is because shear also causes failure. Shear stress causes failure like this. Shear is this. This surface is there, and let us say this book is there. So at this interface, let us say these are two material. At the interface there is shear stress. So one tries to slip over the other. This tries to slip over the other, and in the process shear stresses are created. So if the shear stress is exceeded, if the shear stress is too much, then what will happen? This top portion will just move like this, and failure will occur. If it moves like this, Newton's first law, So obviously this will be Newton's first law. It will start moving and then it will be complete failure. Shear, in shear. So again we don't want maximum shear of the material to be exceeded. Maximum shear of the basic material to be exceeded at any point, because otherwise what will happen, one plane will move over the other in that direction. So that is why we want to find out maximum shear stress on the plane. If this is a plane, please find out the maximum shear stress. So please, how will you do this? Again, do the same thing. Take derivative of shear stress, find out the angle, that will be some angle theta 2. So please find out. Okay, we can have some break for 5 minutes.